Hello, and welcome to this series of micro episodes on general principles of programming, where we explore common concepts in programming like control flows, variables, loops, and a lot of interesting programming concepts. If you're already good at programming, then this micro series is not really for you, and you may want to come back to my C programming series or cloud computing series in a few weeks' time. Meanwhile, for the rest of us, think of this episode as a starter map to the world of programming and code. In this micro episode, we will answer the question, what exactly is programming? The reason it's micro is because each episode is less than 10 minutes. The idea is to learn in small, bite-sized videos. You can binge watch more if you're enjoying learning. I made this micro series as an introduction to programming, as I have seen many computer science newbies struggle with fundamentals of learning C. This series should serve as a good starting point for any programming language, be it Java, C, Rust, or any modern language. In later episodes, we will go deeper into how these concepts look in real code and how to build your first real program. So let's get started. Let me tell you a story about a robot I bought. So this wasn't some fancy AI-based robot, but something very simple. It could take very minimal instructions. It could move, sit, stand, or I could ask it to move left, move right, and that's it. So why am I telling you this example? You'll come to know very soon. So I could give it a command like move forward, and the robot would move forward a couple of steps. I could give it a command saying turn right, and the robot would turn right. So it was like playing with a really well-trained pet. But here's the thing. Every time I wanted it to do something, I had to give every single instruction step by step. Like move forward, turn right, extend an arm, grab, over and over again. And that got quite tedious very fast. So I had an idea. What if I took a whole sequence of steps like move forward, couple of steps, turn right, grab the door handle and open it. All of these steps, if I could put it together and give it a name, say open the door. Okay. So then every time I wanted it to do that, I could just say open the door and boom, one command. Everything happens. That was my first function. It's also a high-level instruction. It's built from a bunch of low-level steps the robot already knew. So later I built another sequence. I could say go up to the dog, pick up the leash, walk around the garden and come back. I call this whole set of steps walk the dog. Now I have two different functions, one to open the door and one to walk the dog. Both of these functions have a sequence of step-by-step instructions inside. So the next time I could just say open the door and walk the dog and the robot would execute both routines. It is simple, clean and kind of reusable. And here's the fun part. This robot, it's not just a toy. I am using it as a metaphor. Something that I can use to explain how a CPU works. Your computer has a central processing unit and at its core, that's all a CPU is. It's a fast, reliable robot. It doesn't go viral or write an essay for you. There is no AI. It's just a CPU. It understands a very small set of instructions like move data, add numbers, compare values, jump to a new location. That's it. There is no creativity, no memory, no judgment. It's just very obedient and it does it very fast. Lot of speed. So when you write code, whether it's in Python, JavaScript or C++, you are not talking directly to the CPU. You are writing instructions for a translator, a compiler or an interpreter. And this software will turn your human-friendly commands into robotic CPU level steps. So think of it like this. When I said walk the dog, the robot broke that into go to the dog, grab the leash, walk forward, come back. That's exactly what software does when it compiles your code. It transforms your logic into machine instructions. That is the robot's native tongue. And this is the magic of programming. You, as the human, You break down a problem into very clear, precise steps. And then you build basic instructions to execute these steps. So until you have built something powerful, you keep on repeating that, and you will end up with something as complex as maybe ChatGPT. So it all starts with that: a little robot, a few basic instructions, a small CPU, a few basic instructions, and a curious human, us. We are ready to build something. Let's keep moving. So, what is programming really? We often think of it as typing weird looking code on a black screen, right? Uh, or automating boring stuff or building apps. Yes, it's all of that. But at its core, programming is just giving instructions. It's the art of breaking down a task so clearly, so logically, that even a computer or a robot can understand what to do. You're not just telling the machine what to do, you are telling it exactly how to do it step by step. Now, here is the key: computers are not smart, they don't get the idea, they don't fill in gaps. They do exactly what you say, nothing more and nothing less. So, programming is about precision, it's about sequence, what happens first, what happens next. It's about conditions. What happens if something goes wrong or changes? It is about repetition, doing the same task again and again efficiently. And it's also about structure, how you organize these instructions so that the whole system makes sense. Think of it like this: you are writing a recipe not for a chef, but for a robot that has never cooked before. And it will follow your instructions literally. So if you say mix the batter before you have told it how to get the ingredients, it will fail. If you forget to tell it how long to bake, it might bake forever. If there is a typo, it might stop. That is programming. It's how we take human ideas, which are vague, flexible, creative, and turn them into precise logic that machines can follow. And every programming language, whether it's Python, C++, JavaScript, Rust, it gives you the tools to do four fundamental things. One, store and manage data. Two, make decisions using logic. Three, repeat actions using loops. And number four is organize instructions into reusable parts. That's it. That's the heart of it all. And once you understand how to do those four things, you can program anything from a calculator to a game to a robot or even AI. That is how we write programs. See you in the next episode.